In our lesson today, we're going to talk about the Pythagorean Theorem. An application of perfect squares and square roots is the Pythagorean Theorem. It tells us how the side lengths of a right triangle relate to one another. Okay, and it's important to note that we're only going to be dealing with right triangles when we talk about the Pythagorean Theorem. Before we get into some examples, we need to learn about the parts of a right triangle. The longest side of a right triangle is called the hypotenuse. The hypotenuse is always found across from the right angle. In a right triangle, the right angle is the biggest angle. Across from the biggest angle is the biggest side. And again, we call that side the hypotenuse. The other two shorter sides of a right triangle are called the legs. So if we look at this right triangle down here, here's the right angle. Across from the right angle is the longest side. And again, we call that the hypotenuse. All right. The other two sides here that are labeled A and B are called the legs. They're the two shorter sides of the right triangle. The Pythagorean theorem states that if a triangle is a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse. Okay, the sum, so we're going to be adding the squares of the legs. So whatever values the legs are, if I square those legs and then I add them together, that's going to be equal to the square of the hypotenuse, which is the longest side of the hypotenuse. In other words, if the legs measure A and B and the hypotenuse measures C, then A squared plus B squared equals C squared. This is the formula that we'll be using for the Pythagorean theorem. A squared plus B squared equals C squared, where A and B represent the length of the legs and C is the length of the hypotenuse. In our first example, they ask us to use the Pythagorean theorem to determine the missing side length of the right triangle. Remember that the Pythagorean theorem says that if a triangle is a right triangle, and this definitely is a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse. In this right triangle, I have 8 centimeters and 15 centimeters, and this side length is the one that I'm missing. This side length is across from the right angle, which is the biggest angle. So this must be the longest side, which is called the hypotenuse. The other two measurements, therefore, are the legs of the right triangle. To figure out the length of the hypotenuse, I'm going to use the Pythagorean theorem. A squared plus B squared equals C squared. A and B are going to be the values of the legs. So in this case, I'm going to do 8 squared plus 15 squared equals C squared, and that's what I'm looking for right here. This question mark, that's C, that's my hypotenuse, the longest side of the right triangle. I'm going to first square these numbers. 8 squared is 64, and 15 squared is 225, and that equals C squared. I can add 64 and 225 to make 289. 289 is equal to C squared. Well, I want the value of C. To undo the squaring, remember that we have to do the square root. So I'm going to take the square root on each side, and the square root of C squared is C. The square root of 289, well, that's a perfect square. The square root of 289 is equal to 17. 17 times 17 equals 289. Okay, so the missing side, is 17 centimeters. Okay, this side right here is 17 centimeters. And again, that's the longest side. It's the hypotenuse. It's longer than the two legs. In our second example, they tell us that a 15-foot ladder leans against a building such that it reaches a height of 12 feet. Assuming that the building is vertical and the ground is horizontal, we want to find out how far from the base of the building is the bottom of the ladder. All right, so looking at our picture here, we have a 15-foot long ladder, and it reaches up to here, which they tell us is a height of 12 feet. We want to know how far from the base of the building is the end of the ladder. How far is that? The building is vertical, the ground is horizontal, which means that these form a right triangle. In order to figure out this missing length right here, I'm going to have to use the Pythagorean theorem. So a squared plus b squared is equal to c squared. Remember that across from the right angle is the longest side, which is called the hypotenuse, and I can see in this case that that's 15. So my c value is going to be 15. 15 squared, 15 is the hypotenuse. And that means that 12 and my unknown value are the two legs. Now 12 can either be a or b. It doesn't really matter. I'm going to make it a, 12 squared, plus b squared, this is my unknown leg, equals 15 squared. I'm going to square my two numbers. 12 squared is 144, plus b squared equals 15 squared, which is 225. Now remember that this is an equation and our goal is to try to get the variable alone. So I'm going to subtract 144 from each side. All right, when we subtract 144 from each side, that leaves us with b squared, and 225 minus 144, that's going to be equal to, well, 5 minus 4 is 1, 22 minus 14 is 8, so b squared equals 81. Now, to undo the squaring, we're going to have to do the square root of each side. The square root of b squared is b, and the square root of 81 is 9. So this length right here is going to be 9 feet. 9 feet, all right? The end of the ladder is 9 feet from the base of the building. So the Pythagorean theorem states that if a triangle is a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse. The converse of the Pythagorean theorem is also true. All right, the converse of the Pythagorean theorem is basically just going to go in reverse. If a triangle has side lengths of a, b, and c, and a squared plus b squared is equal to c squared, then the triangle must be a right triangle. And so in my third example, I want to determine if each set of numbers below could represent the side lengths of a right triangle. The only way that these could represent the side lengths of a right triangle is if that they make the Pythagorean theorem true. Is a squared plus b squared going to be equal to c squared? So in my first set of numbers, I have 8, 15, and 17. I'm going to start by writing the Pythagorean theorem, a squared plus b squared equals c squared. And now I'm going to substitute my values into the Pythagorean theorem. Now remember that c is your hypotenuse, which is always the biggest number. In this case, that's going to be 17. So I'm going to have equals 17 squared at the end. And then the other two values are going to be the legs, and those are interchangeable. It doesn't matter which one is a and which one is b. So I'm going to write 8 squared plus 15 squared equals 17 squared. If both sides of the equation are equal to each other, then these three lengths could represent a right triangle. So let's see what we would get here. 8 squared is equal to 64, 64, plus 15 squared is 225, and 17 squared is 289. Now if I add 64 with 225, I do get 289. So 289 equals 289. Which works out, which means these lengths could represent a right triangle. Okay, since we had a true statement here at the end, 8, 15, and 17 could be the lengths of a right triangle. Let's try that with 25, 7, and 24. Could these be the lengths of a right triangle? Start with your Pythagorean theorem, a squared plus b squared equals c squared. And remember that c has to be your hypotenuse, which is the biggest number, which in this case is 25. So I'm going to put equals 25 squared at the end. The other two are going to be your legs, a and b. 7 squared plus 24 squared equals 25 squared. And now let's do the math and see if we have an equation, a true statement. 7 squared is 49. 24 squared is 576. And 25 squared is 625. If I add 49 with 576, then I get 625, and that is equal to 625. So again, we could have a right triangle with these lengths. All right, 25, 7, and 24 could be the sides of a right triangle, where again, 25 is the hypotenuse, and 7 and 24 are the legs. How about 6, 7, and 8? Well, again, a squared plus b squared equals c squared. Your hypotenuse needs to be the biggest number, which in this case is 8. A and b will be the other two numbers. They're the legs, 6 squared plus 7 squared. And now let's square everything. 6 squared is 36. 7 squared equals 49. And 8 squared equals 64. If you were to add 36 with 49, you would end up with 85. 85 equals 64. Well, no, it doesn't. 85 does not equal 64. So these would not represent the lengths of a right triangle. Okay, no right triangle. Now, these numbers could still represent a triangle, and in fact, they would be a scalene triangle because they're all different, but they would not be able to make a right triangle. Now, underneath, we're told that when a set of three integers could represent the side lengths of a right triangle, we call this set a Pythagorean triple. To see if a set of three numbers is a Pythagorean triple, we only have to see if it makes the Pythagorean theorem true. Okay, looking at what we had up above, 8, 15, 17 is a Pythagorean triple because they made the Pythagorean theorem true. Also, 7, 24, 25 is a Pythagorean triple because they made the Pythagorean theorem true. But 6, 7, and 8 is not a Pythagorean triple because, well, as we saw before, this was not a true statement when we tried to use the Pythagorean theorem. In our next example, we're told that on a construction site, Jamie wants to join a 12-foot long board with an 8-foot long board so that they make a right angle with each other. So here's our picture. There's the 12-foot long board. There's the 8-foot long board. We need to make it so that they would make a right angle when we join them together. Now, Jamie can only do this if the diagonal from point A to point B is what length? So here's point A, the end of that board, and point B is the end of this board. So if we were to draw that diagonal in there, how long does that have to be in order for there to be a right angle when we join these two boards together? Round your answer to the nearest tenth of a foot. All right, so by drawing in that diagonal, we see that we have created a right triangle here. In order to figure out the value of this missing side, then I'm going to have to use the Pythagorean theorem. A squared plus b squared equals c squared. Now, this side here that's missing is across from the right angle, which means that that has to be the hypotenuse. So I'm looking for the value of c in my equation here. I know the values of a and b then. Those are the two legs, 12 and 8. So let's put in 12 squared plus 8 squared. And now we're going to go ahead and do the squaring. So 12 squared, 12 times 12, that's 144. And 8 squared, 8 times 8 is 64, equals c squared. If you add 144 with 64, that gives you 208. 208 equals c squared. And now to get the value of c, we're going to have to take the square root of each side. Okay, the square root of c squared is c. And 208 is not a perfect square. That means when I take its square root, I'm not going to get a whole number. I'm going to get an irrational number. So let's use our calculator and figure out what that's going to be. All right, so for my calculator here, 208, and then I have to hit the square root symbol. This is a little different than the calculator that I normally use, but that's the number that you should get when you type in the square root of 208 on your calculator. So I would get 14 and 4222051. That's the value of c. They said to round to the nearest tenth of a foot. So I'm going to say then that c is approximately 14 and 4/10. Okay, this 2 here in the hundredths place is not enough to round us up. So c is approximately 14 4/10, and the units are feet. That's what this hypotenuse here is, approximately 14 4/10 feet. In our next example, they want us to find the missing length of each right triangle. So looking at my pictures here, all right, here's a missing side on my first right triangle. That one is across from the right angle, which means it has to be the hypotenuse. So that's going to be labeled as C. And on this right triangle, I'm missing this side down here. Notice this time, though, they gave us what the hypotenuse was. So this one here has to be one of the legs. So let's call that one A. All right, in each case, to figure out that missing side length, I'm going to use the Pythagorean theorem. So let's start here. A squared plus B squared is equal to C squared. I'm given the values of the two legs, so we'll start by substituting those in. 16 squared plus 12 squared equals the hypotenuse squared. 16 squared is 256, and 12 squared is 144. And again, we still are looking for C, so we have C squared there. Now, if we add 256 with 144, we end up with 400 equals C squared. To undo the squaring, we're going to do the square root of each side. Square root of C squared is C. The square root of 400 is 20. So this missing side here is going to be equal to 20 inches. Over here, again, let's use the Pythagorean theorem. A squared plus B squared equals C squared. A is one of the legs, that's what we're looking for, so we'll keep A squared plus my other leg over here, 10 squared, equals the hypotenuse of 26 squared. Let's go ahead and square our numbers. So we still have A squared plus 10 squared is 100, equals 26 squared, which is 676. I have to get my variable term alone, so I'm going to subtract 100 on each side. A squared then is going to be equal to 576. And now to get the value of A, I'm going to have to take the square root of each side. The square root of A squared is A, and the square root of 576 is 24. So this missing side right here is going to be 24 meters. In our next example, we're told that a car starts by driving north for 5 miles and then drives east for another 12 miles before stopping. They want us to draw a diagram of this scenario and then determine the straight line distance from the car's starting point to its ending point. So let's go ahead and start by drawing a picture. So I'm going to have a starting point, and then I'm going to drive north 5 miles. So I'm going to go straight up north 5 miles. And then I'm going to go east for 12 miles. So that means I'm going to go to the right. That's where east goes. And that can be 12 miles. They want to know what's the straight line distance from the car's starting point to its ending point. So there's where it ended, there's where it started. I need to determine what this length is going to be here. And the directions have formed a right triangle. Okay, I know that that's a right angle there. This unknown value is across from the right angle, so this must be the hypotenuse. So we've got to try to figure out how much that value is going to be. So in order to figure out that value, let's use the Pythagorean theorem. A squared plus B squared equals C squared. C, the hypotenuse, is what we're looking for, so we'll keep C squared. 5 and 12, therefore, are the legs A and B. 5 squared plus 12 squared. Let's square the numbers. 5 times 5 is 25. 12 times 12 is 144, equals C squared. If you add 25 and 144, you get 169 equals C squared. And now to figure out the value of C, let's do the square root of each side. The square root of C squared is C. The square root of 169 is 13. So that means that this straight line distance, this hypotenuse here, is 13 miles. In our last example, we have a picture of a triangle, and in fact, this is an isosceles triangle because two of the three sides have the same length. Find the area of the isosceles triangle shown below. Well, if we remember from geometry, in order to find the area of a triangle, we need to use the formula area equals 1/2 base times height, where the base and the height are perpendicular to each other. I can see here along the bottom horizontally that is 12 inches, but the other two sides of the triangle aren't perpendicular to this side. I need to figure out what value is perpendicular to this value. So I'm going to draw a line from the vertex perpendicular to the base, and then I'm going to draw in the right angle mark. So this is the vertex. I'm going to draw straight down, perpendicular, which means I'm going to meet at a right angle. And I'm going to label this segment as H because it's the height. I need to figure out what the height is of this isosceles triangle before I can figure out the area of the isosceles triangle. So let's see if we can figure out the value of H so that we can then find the area of the isosceles triangle. Now, notice what this line did right here. This line actually creates two right triangles when I draw it in. All right, I need to figure out what is the value of this side of the right triangle right here. Here's the right angle. Across from the right angle is the hypotenuse, so I know the value of C, the hypotenuse. This height is one of the legs, and I also need to know what this length is from here to here. What is the value of this leg right here? Well, this line that we drew in is called a perpendicular bisector. It's perpendicular to the base, and it bisects the base, which means it splits it up into two equal parts. The entire base was 12, so this length from here to here then must be 6 inches. So if I cover that up, I can see that I really just have a triangle that's a right triangle where one of the legs is 6, the hypotenuse is 12, and this height is one of the legs that I'm looking for. So let's use the Pythagorean theorem. A squared plus b squared equals c squared. The hypotenuse I know is 10, so that'll go in for c, 10 squared. One of the legs down here we said was 6, 6 squared plus, and the other leg I've called h. So instead of calling it b, I'm going to call it h squared. Let's square our numbers first. 6 squared is 36, plus h squared equals 10 squared, which is 100. Now we have to get h squared all alone, so we'll subtract 36 from each side. H squared, therefore, is going to be equal to 64. To get the value of h, now I'm going to take the square root of each side. Square root of h squared is h, and the square root of 64 is equal to 8. So this height right here is equal to 8 inches. Now that I know what the height is and what the entire base was, I can find the area of the isosceles triangle. Area equals 1/2 base times height. So in this case, we're going to have 1/2 of the entire base was 12, and the height we just calculated to be 8 inches. Well, half of 12 is 6, and 6 times 8 is equal to 48. So the area of this isosceles triangle is 48 square inches.